Hey guys, welcome to the Nerd Find. This is Pradeep Chaudhary, and in this video, we'll be performing CRUD operations on Postgres database using FastAPI. So would be basically like building on or modifying the API that we had created for performing CRUD operation on this kind of a data structure in our previous videos. So I would highly recommend go ahead and watch these videos first and then return back to this video. I would be having the link in the description. So do check those out first. So basically, we'll be using a Python package called databases, which provides like connectivity and interface to various kind of databases like PostgreSQL, MySQL, and SQLite. So it basically uses the SQL Alchemy core development kit to perform the queries. So it's very simple to use. You can use the ORMs provided, and it simplifies a lot of tasks and also integrates very well with FastAPI. So this is the package that we would be using for performing our root operations. So let's go ahead and we'll start modifying our API to uh, perform a root operation on Postgres database. So, okay, one more thing before that. So we'll be using the Postgres database that we had set up in our local using Docker engine. So if you guys haven't watched that video, I would highly recommend to watch that video and come back to this video. So, and after running our Postgres database using Docker engine, we also ran an Alembic database migration script to create our student data table. So there is a video for that as well. If you guys haven't checked that out, do check it out as well. So basically, student data, we have four columns: SID, which is a primary key, and auto increments. There is a name column, which is basically a string column, similarly degree column, and a section column. So we'd be using this particular student data to perform a CRUD operation using this API. So let's go ahead and we'll modify our database. Like we'll add our databases Python package in our environment.yaml, and we'll first modify our conda environment that we have created. So we'll import the like we'll add the databases package, and we'll be using version 0.3.2. So this is the latest version that like that is available when I'm making these videos. If there is a newer stable version available, to go ahead and use that. That's perfectly fine as well. So we'd be needing PostgreSQL because we'll be like performing a root operation on this particular database. Similarly, there are interfaces for MySQL and SQLite provided by this library. So if you guys want to use those, to check those out as well. So we'd be also needing the async PG library. So we'd be using 0.21.0, and that's it. So let's go ahead and we'll update our conda environment. So first we'll cd into this directory, and we'll cd into the app directory. This should have our environment.yaml, and then we'll form our conda environment update. So this should update our FastAPI demo conda environment, and after it is done updating, we can start modifying our scripts. So now our packages have been updated. Sorry, our Conda environment has been updated. Now we can go ahead and we'll create our database connection first, and then we'll perform our root operation on that. So to perform our, like to make our connection to the database that we are running in local or like running anywhere in that sense, we'll create a db.py file in our API directory, which will have the logic to connect to this, connect to the Postgres database. So basically, we'll be maintaining, like we'll be creating a connection when the API is started, and we'll be maintaining that connection for throughout the entire API lifecycle, and we'll be killing that connection when the API is shutting down. So this is the life cycle of this particular database connection that we'll be using. So to create our connection, we'll use the SQL Alchemy and we'll import a few libraries first. So we'll import as we need. So first we'll import the create engine library. So this is basically the library that will create our database engine using a particular connection string. So our connection string will be pointing to the Postgres database that we are running in local. You can modify it to point it to in database that you want. So apart from this create engine would be importing the databases package, and we'll be importing the database class from that. Sorry. So, okay. Now, after that, we'll be importing, we'll be reading our PostgresDB connection string from an environment variable that will be setting in some time, in a few minutes now. So we'll set an environment variable called Postgres underscore DB, which will have a connection string that will point into the local database. So when we deploy it to a double environment or broad environment, we just need to set the correct environment variable to point to the correct dev DB or correct broad DB or whatever DB you want to connect to. So this is the way that we would be maintaining our connection strings, and like you can hard code it as well. So now our database underscore URL is a variable that will have our connection string. So this will be using to create our engine. So to passing the database URL here, and after that, okay. After that, we'll be creating the database object that will be using throughout our API lifecycle to make our queries. So this is the database. Like this will also take the database URL as parameter, and we have our database object now. So apart from this, we'd also create a table relation that we'll be using throughout a life cycle to query our student data table, and like maintaining the metadata of the table and all those things. So we'll be creating a relation for that. So to create the relation, we'll need a couple of more classes from the SQL Alchemy package. So we need a column, a class, integer, metadata, then string, then table, and that's it. So apart from, like after that, we'll create an object of the metadata class, and then we'll be passing that in a student relation that we'll be creating. So we'll be creating a student relation, which will be of type table, and it will query the student data, and then we need to then we'll pass the metadata object, which will which will contain all the important data related to this relation in this object. So after that, it takes the rest of the parameters of the column that we have in our table. So SID, and it will be an integer, and primary key, that's true. And then we'll pass the rest of the columns that we have. String. We'll just copy this. And this will be degree. this will be section. And apart from that, we just need to pass one more variable because it's not in public schema. So we need to provide the schema name here. So would be specifying that using schema is equal to fast you get. So this is our student relation that we need. So this is with respect to the db.py that we be needing to maintain the connection to our database. So after creating the connection, so first step is when the main.py runs, and we have defined this async startup annotation. So here we'll be connecting to the database when we start our API. So first we'll import the database and the engine. Okay, we need the database is here only. So we'll connect the database first. So await databases dot connect. Then when shutting down, we'll do a disconnect. Okay, perfect. So now when the API will start, we'll connect the database. When the API shuts down, we'll kill the database connection. So we are handling the connection correctly now. So now let's go ahead and we'll modify our, okay, one more quick thing before that. So as we are importing the PostgresDB environment variable into database URL variable, so we'd be needing to set that environment variable. So to set that environment variable, we'll do use the export statement. So I'm using a Linux machine. If you guys are using a Windows machine, it's set for you guys. So you can modify it accordingly. So our connection string will be normal Postgres database connection string. So PostgreSQL colon slash slash Postgres. And so this is basically the username. Then the next parameter will be the password. So we had set our password as my secret password. If you guys have set it as something else, go ahead and change that. And then our post database host, then the port, and then the database that we are trying to connect to. So that's it with the environment variable that we need to set. So let's go ahead and set that in our terminal. Yeah. So we'll activate the environment as well. Go ahead and activate that. Our environment is ready. So now let's go ahead and we'll make the modifications to student.py file like to perform a CRUD operation on PostgreSQL database rather than on the fake student data. So before doing that, we'll do one more change to models.py. So rather than having one single base model, that is the student class, we'll be having a couple of Pydantic models. So rather than calling it student, we'll call it student in. So whenever we need the input, like when we are creating the student data, or when we are inserting the student data to the Postgres database, like there's a base model that we'll be using. So name the section there. Apart from this particular base model, we'll have one more Pydantic model. We'll call it student out. So this is the response. So if you want to send a student detail as response, what all like details should be there. So rather than it being inherited from base model, will inherit from student input class that we created in the above lines. So here, like when it inherits a base model class, what it automatically understands that this three variable should also be included in this particular class. And apart from that, we also will need one more variable that will be the s underscore id. So these are the two. Okay, we would also need one more model, Pydantic model, that will be the student update. So when we need, when we need to take details of student for the update method, we'll be using this model. So it will also inherit student input, and rather than using the same name degree section as compulsory parameter here, all the three would be optional parameters. So to why we need to specify it as option, because update people generally don't have to update the all the records. They might also need to update just one record. So in that case, they might they would only want to update that particular variable, and rest of the variables should be should not be touched. So for that reason, we define all the three variables as optional. So to define something as optional, we'll import the typing library and import the option class from there. So name will also define as optional, and the default value will be none. Degree also as optional, and this one will be none. Similarly for section. Okay. So these are the three Pydantic models that we'll be using for our API. So now let's go ahead and we'll start modifying our student class, student.py file. So first let's modify this import statement from the model to model file. So rather than importing student, we'll be importing student in, student out, and student update. So let's go ahead, let's remove this. We won't be needing this anymore because we're forming our code operation on the Postgres database. So after this, let's go ahead and let's create one more file. This particular file will name it as db underscore manager. So this will this will contain all the business logic or all the logic that to perform the actual queries using the database object that we created in the db.py file. So it will perform the actual querying on the database. So would be using this particular class, this particular file to maintain all the scripts there. So here as well, let's import the models class, and we'll import student in and student update and student out. And apart from this, we'll also need the database db.py class and db.py file. From here, we'll need the students relation that we created and the database object that will contain our connection. So, and now back to students.py. Okay, so we'll do it this way. So we'll let's comment all our routes, and we'll modify one route at a time. We'll test it, then we'll add another route, and so on. So let's go ahead and modify our add student method to insert the records or insert the student data in the Postgres database rather than appending it to the fake student data uh, list. So to do that, so let's first go ahead and add a method in the db manager .py file. So this, as this contains the actual logic for performing our DB queries. So we'll go ahead and first add the method here. So this will be asynchronous method. We'll call it add underscore student, and this will take a parameter that will be the payload data that will come from our API request input, and it will be of type student and Pydantic base model type, and query is equal to student. So we'll be using the student relation that we created in db.py, and we'll be using the insert method, and for values we'll be parsing the payload data as a dictionary. Then we'll just form the actual update database dot execute, and we'll run the query on that. So let's go ahead and let's call this method from our add student method in the students.py. So let's return s underscore id await db underscore manager. Okay, we didn't import that yet. API import db underscore manager, and we'll be using the add student, and we'll be passing the payload data as an argument here. And as for response, we'll be returning a dictionary. One of the keys would be ID, and the ID would be passing as s underscore ID, and the second parameter will be the payload data, and just return that. So now let's go ahead and let's run this API first, so that we can test it before moving to the next. So let's run the uvcon command. Okay. For some reason, I'm not able to copy it. Okay, let's close this terminal. We'll open one. Let's cd into this directory really quick. We'll form the conda activate. We'll run the export statement again. Perfect. We'll just do our echo to test it. Perfect. Now let's run our uvcon command. Okay, so there is some invalid syntax. Okay, there is some typo in metadata. Okay, has to okay, from cannot import database, from databases. Okay, there is a typo here in database, so it should be small b. Okay, now let's go ahead and run this. Okay. Okay, student and 15 students.py line 15. Okay, it should be student in. Okay, from api.db cannot import main databases. Let's go ahead and see what's wrong. Okay, it should be database and main.py. And let's check our students.db underscore script. So now let's run this. Database is not connected, should be perfect. Now let's run this. Okay, now our application started correctly. Now let's run our Swagger UI. We'll test this particular route first. So let's fill in these details in the post route. So let's give some name, degree, and then we'll provide this section. Okay, perfect. So our API response body is fine. We get the ID, name, database section. The payload data is coming correctly as well. There is no error in the in the terminal. Let me go ahead and close the previous terminal. Yes, so there is no error in this, like there is no error in the terminal as well. So we'll do a quick check in the DB viewer. So this is the SQL tool that I prefer to use. If you guys are using something else, feel free to use that. So we'll do a view data here. Now we can go ahead and we'll query the data in the student data table so we can verify whether our records actually got inserted. So we'll do a select star from, we'll specify the schema. So it's FastAPI demo for us and the table. So we'll be using the student data table. Okay, perfect. So we can see our data being inserted. So we'll go ahead, we'll quickly add one more data here. So we can call it the node find to grad and we'll change the section here. Execute and perfect. So we'll run our query again. Perfect. We can see, and we can see our s underscore IT auto implementing as well. So perfect. So this post method is working correctly. So now let's go ahead and add a get method for returning all the data in our Postgres database in a JSON format. So we'll be adding one more method in the db manager.py. So we'll be calling this method get all student. So async def get all students, and we'll have a logic, like we'll first create our query to return all student data. So we'll be using the students relation students dot select. So we don't need any query because we need to return all the student data. Uh, like if we have like we'll be implementing offset skip and all those things in a later video. So if you guys want to implement that, so you can do so using the select statement. Then return away database dot fetch all, and we'll pass the query here. So that's it with our get all students method, and in students.py we'll just call that particular method and we'll return that. So db underscore manager dot get all students, and that's it. And here we'll change this like response model to student out. So this looks good. Now let's go ahead and let's run our API again, and we'll refresh the Swagger UI, and let's run out with students. Perfect. So we can see our both the student data here with SN underscore ID 1 and 2 respectively. So this works perfectly as well. So we'll go ahead and we'll add one more method that will return the details of one particular student from our database. So would be passing the s underscore ID rather than ID in the URL. So we'll change it here. And our response model will also be student out, and we'll printing s underscore ID. Okay, now let's remove these lines, and we'll go ahead and we'll add one more method in the db manager.py. So we'll call this async def get student, and we'll pass s underscore id into this particular method. So s underscore id, and we'll generate the query. So query is equal to students dot select, and we'll use the students relation c dot s underscore id equal to s underscore id, and we'll do a fetch one of it, database dot fetch one, and we pass the query here. So it looks good. Now let's go ahead and we'll call this particular method in our get underscore student method. So we'll do a student is equal to update db underscore manager dot get underscore student, and we'll pass the s underscore id here, and we'll add a condition. If not student, will raise a HTTP exception, and we'll be passing s underscore id here, and if everything is fine, we'll just return the student. So now let's go ahead and we'll refresh the API, and we'll refresh this Swagger UI. So this is the method, this is the route that we want to call. So let's go ahead and uh, check out for ID1. There's some error. So value is not a valid text. Okay, there is some error. Value is not a valid text. Okay. So on db dot underscore manager dot py. Okay. This is a method. Let's add the weight. Looks fine now. Okay, perfect. Let's run our Swagger UI. Okay, now this route is working fine. So we can go ahead and we can check for the other data as well. So this looks fine. So now we have added our get underscore student for a particular student ID. Uh, let's add our update method, and then modify this payload as student update, and instead of ID it will be s underscore ID. So this will also be s underscore ID, and where's the send? Okay, this should be s underscore ID, and we'll remove this. Okay, this will use this HTTP exception. Okay. So let's go ahead and we'll add a method in the db underscore manager.py. We'll call it update student, and we'll need s underscore id, which will be an int, and we'll need the payload data, which will be a student update type. So now let's build our query. So we'll query the students relation, and we'll update um, with the condition, and the condition will be a where clause, and it will be students dot c dot s underscore id equal to s underscore id, and we'll pass the values here, and we'll pass the payload dot, and we'll run the query now. Run await database dot execute query. This query. Okay, this looks good for the update student method in db underscore manager dot py, and let's modify the students dot py update student method. And as a first step, what we'll do is we'll verify that the student ID that we are trying to update is actually present in the database or not. So for doing this, we'll use the get underscore student method that we created in the previous, like for the previous route. So we'll be using that. So student is equal to await db underscore manager dot get student. We'll pass the s underscore id here, and we'll check if the student is available or not. If not, we'll raise an exception. Now we have checked the student data is there, then we'll create the update data variable. So what it will have is it will have only the, so what it will do is, let me write it first, then I can explain. Exclude underscore unset is true. So what it will do is, if there is a particular variable is coming as default, so it will remove that from the dictionary in the update data. So like for say you want to modify name and degree and not section. So in the update data, it will only have two keys, that will be the name and degree, and it won't have the section key. So now we'll use this update data to create a student in DB. Let's call the student in DB variable. So what it will have is it will will typecast the update data um, to the student update model that we created. So will be sorry, rather than passing this, will pass the student data here, and then it will uh, create the update student variable, updated student, let's call it, otherwise it's a conflict, student in db dot copy, and we'll pass the update as update data, and we'll perform the query. Return update db underscore manager dot update underscore student, and we'll pass the s underscore id and updated student. So now let's run this. Looks good. Looks fine here as well. Okay, this looks fine. Now let's refresh our Swagger UI and we'll use our update student method. So let's try modifying s underscore id as 2. We'll call it the nutvine3, and we'll pass as beta some section, and let's run the execute. Looks fine. This also looks fine. Let's run our get student method to see if the values actually got modified or not. Okay. Yeah. So we have our modified value. We have our name as 10.3, section as P, and daily different as well. So this update student method also looks good. So now let's go ahead and we'll add our daily. So let's comment this. We'll remove these lines. And here as well as a first step, so what we'll be doing is we'll be checking if the id of the student that we are trying to delete is actually existing or not. So we'll just copy the same that we did in the update method. So we'll copy that. So after this, but like after checking if the student ID is present or not, so we'll go ahead and we'll form our actual deleting. So let's first add a method in the DB manager .py file. So we'll call this method delete underscore student, and we'll need the SID as the argument will be a int, and we'll build the query. So students relation dot delete, and what is the clause for delete? It's when the ID matches. It's ID, and we'll form the flexible statement. Perfect. So now let's go ahead and let's call this method in our delete student in students.py. So we'll manager dot delete student, and we'll pass the s underscore id. Looks good. Now let's go ahead and try running this. So let's update this page. Now we'll try to delete student ID 2. There's some error. S underscore ID is not defined. Okay, S underscore ID is not defined. Let's see where. Okay, so we forgot to change this parameters. Looks good. Let's begin. And we'll run this execute. Perfect. Now we get the response body null. It's working correctly here as well. So now let's go ahead and we'll use our get method to see if it actually got deleted or not. So we can see it gives student with given ID 2 not found. If we do get all student method and route, so we can see only one student data. So perfect. So this is the 5 CRUD operations that we did on the fake student data. Now we are able to do it on directly on Postgres database, so we can store it permanently on a persistent database rather than storing it in memory. So this with this like this is it with respect to this video. If you liked it, to like, subscribe, share it with